Hello friends, this is going to be the second lecture in the series of satellites and launch vehicles, and today we are going to discuss about the launch vehicles. And as I have already told you that these launch vehicles are nothing but the rockets that carry the satellites. These rockets look like somewhat this. They are having a head and there is a thruster. On these rockets there are some strap-ons attached, and inside this rocket we see various satellites are kept. These are the satellites. So the satellites and whole of this is the rocket. Now what happens is that whenever this rocket has to move up, it starts burning its fuel here, and because of which energy is produced, and this energy moves out of the thruster towards this direction. Now as this hits the surface of the earth, an equal and opposite reaction is created to it, which pushes this rocket out of the earth, and it is required to have an escape velocity. So there may be a question in your paper that these rockets act on which principle? They act on Newton's third law of motion, and that is, to every action there is an equivalent reaction. Now if we see the launch vehicles used by India, one is Pslv and the other is Geostationary. Although these are not the first ones, the first to be used was Pslv, and that was used in 1979 to launch Rohini. And the project director for launching this was Dr. APJ Abdul Kalam. This is very important to know that we generally believe that APJ Abdul Kalam was the missile man of India because he developed this integrated guided missile development program, but he was also the project director of the first satellite launch vehicle in India, and that was Pslv. Now when we talk about Pslv, its full form is Polar Satellite Launch Vehicle. So it is used for launching polar satellites into sun synchronous orbits. This sun synchronous orbit I have already explained it to you in the last lecture. This sun synchronous orbit is 600 to 900 kilometers away from the Earth. That is considered to be LEO, and the weight which it can carry is about 1750 kg. This is the highest capacity to which it can take. So it takes primarily along with Earth observation satellites, or what we also called as remote sensing satellites. Example to this is Cartosat, ResourceSat, SoSat. The primary task of these kind of satellites is to observe the Earth, and that is why they are present in the sun synchronous orbit, because they need to have same sun illumination. And in the last lecture I have already explained it to you that what is this same cell illumination. Now another point which is very important to know about this PSLV is that although we consider that PSLV only is used to send polar satellites, but no, it can also be used to send geostationary satellites. Geostationary satellites. And how is it done? It is done by sending a satellite into GTO. Now what is this GTO? This GTO is Geosynchronous Transfer Orbit. Here the name is that geosynchronous and transfer. So this is the orbit from where a satellite is transferred to geosynchronous orbit. So this is the geosynchronous transfer orbit. This blue line is showing geosynchronous transfer orbit to which a small satellite can be sent, and then this red line clearly shows us that it has moved into a geosynchronous orbit. So blue line shows a GTO, that is geosynchronous transfer orbit, and the red line shows us geosynchronous orbit. Thus this geosynchronous transfer orbit is to send geostationary satellites or geosynchronous satellites into their orbits by sending small satellites. The important point is here that small satellites can only be sent, that is almost around payload of 1400 kg, not more than that. So PSLV, now it is clear that PSLV can be used to launch a polar vehicle, polar satellite, as well as a geostationary satellite, but that should be small geostationary satellite, small satellite of 1400 kg, and this is sent into a GTO. This PSLV is a 4-stage rocket. 4-stage rocket where there is this first stage, second stage, third stage, and fourth. This first and third stage are solid stages, and second and fourth stages are liquid stages. So this is important to remember that 2 stages are solid and 2 stages are liquid, and the first stage is solid and the third stage is solid, and second and fourth stages are liquid. The solid fuel which is used is PBAN, polybutadiene acrylonitrile. This is the solid fuel which is used, and liquid fuel which is used in the rockets is liquefied oxygen. And one thing important to know along with it is that this liquefied oxygen will always be accompanied with liquefied hydrogen. So hydrogen and oxygen are used together in this liquid stage. This oxygen acts as a oxidizer. This is oxidizer, and this liquid hydrogen acts as the fuel. But both things are carried together in the space. So the solid fuel is PBAN and the liquid fuel is liquefied oxygen and liquefied hydrogen. Now let us talk about GSLV. As the name suggests, it is Geostationary Satellite Launch Vehicle. It can be considered as a big truck, 16-tier truck, which can carry a heavy payload along with it. So this geostationary satellite launch vehicle is used to launch communication satellites. Communication satellites, and these satellites are very heavy, nearly 3000 to 4000 kgs, and they need to be taken to the heights of around 36,000 kilometers. Thus, a very big vehicle is required, and that is GSLV. And if we look into its rocket or stages, if this is the rocket, it is having 3 stages. The first is solid, the second is liquid, and the third is more important, which is cryogenic. So when we talk about cryogenic, it always means very low temperature. And India for a very long time was not having this cryogenic technique, and thus India was not being able to implement its GSLV program for long. And after much of the failures, last year India was able to successfully launch its first commercial GSLV flight in the form of GSAT-19 as the first developmental flight. This all is done by the rocket named GSLV Mark III, which is the third largest booster in the world. It is having a capacity to carry 4000 kg to MEO and about 8000 kg to LEO. The cryogenic stage which it is using is also called C. Now this is also very important to know that why this cryogenic stage was so difficult to achieve, and why this temperature need to be kept so low. So for this I will tell you that the fuel which is used here is liquid oxygen and liquid hydrogen. And the temperature at which liquid oxygen, because both of these gases are gaseous in room temperature, thus in order to liquefy them, the temperature required is that minus 183 degrees centigrade for oxygen and minus 253 degrees centigrade for hydrogen. Thus to reach these low temperature is very difficult, and hence C-25 cryogenic engine was developed in order to keep this temperature at this very low and keep the oxygen and hydrogen at a liquefied temperature. Now this oxygen, I told you, is acting as an oxidizer. This oxidizer is not required when we are on Earth, because for burning oxygen is present all around us. But when we go into the space, there is no oxygen, and hence the fuel which is present cannot burn automatically as it burns on the Earth. Thus an oxidizer needs to be kept along with the fuel in order to burn it in the space. So a new technology is also being created, and that is called air breathing propulsion technology. This technology was tested by ISRO last year. This technology is going to use the air present within the atmosphere, within the 50 kilometers of the atmosphere, so that the amount of oxygen required to be taken along with the rocket is reduced, and when a rocket enters into the atmosphere, it will use the atmospheric oxygen. Atmospheric oxygen can directly be used. So this technology is using directly atmospheric oxygen within the atmosphere, and above that it is going to use the liquid oxygen. This is going to reduce the lift of weight. Lift of weight will be reduced. One more technology which was in news last year was RLV, that is Reusable Launch Vehicle. As the name suggests, ISRO has successfully launched a vehicle into the space, which has come back, and now we can use that vehicle again for sending a satellite. So what's the benefit of it is that every time we will not require new rocket, and as the old rocket can be used, it will improve the economy, and thus reusable launch vehicles are also a very important technology which was tested by ISRO last year. So this is it about the launch vehicles. In the next video, I will tell you about different missions which India has sent into the space, such as Chandrayaan-1, Mangalyaan, Chandrayaan-2, Astrosat, and other missions which we are sending, and which other agencies are also sending. Till then, thanks for watching, and please like, share and subscribe with other people, so other people also get the benefit of it. Till then, God bless you.